One of the things I find is very difficult for students to understand is the concept of an eigenvector. So what I have here is just a makeshift telescoping pointer that I put an arrow on so you can follow it. And in the background we have some paper that kind of looks like a graph paper. You shouldn't be distracted by it. There's no measurements that we're going to be making. One of the things that you should keep in mind is when a matrix multiplies a vector, there are two things that it can do. It can take that vector and it can rotate the vector, or it can take the vector and it can change its size. And in general, what happens is a matrix will both rotate and change the size when the operator acts on the vector. So I might start with some vector that looks like this, and then after the matrix multiplies the vector will end up something like this. One of the things that's most amazing about matrices is there's a class of matrices called Hermitian matrices. For those matrices, there are two directions for two dimensions, and in higher dimensions, if it's an n by n matrix, there'd be n directions, where when the matrix multiplies the vector, all that happens is the length changes. No change in direction. It can change in a positive way, as I'm showing here, or it can even change in a negative way, shown here, and that would be something that looks like it's a rotation, but it's really just multiplying by plus or minus 1 along this line, which was the direction that the original vector was in. Now, the thing that's most confusing to people is the most common rotation they think of is just a rotation. And if the matrix is doing some kind of rotation to my vector, there is no direction that will correspond to the eigenvector. And that's actually completely correct. The reason why, however, is the matrix that governs a rotation is a unitary matrix. That's not a Hermitian matrix. And the rule for eigenvectors always comes from Hermitian matrices. So the unbelievable fact that is actually true is when you have a Hermitian matrix, there are these two eigenvectors. There are two directions where when you multiply by the matrix, it will change just the size of the vector when it's multiplied by the matrix. And the interesting thing as well is that those directions are always orthogonal to each other, as I'm indicating here. One direction might be looking like this, and the other one then would be looking like this.